mineral assemblages, basis of the reactions. Yeah. But now you see this one. This one is only silica, only quartz. Here only one component, quartz, or there may be some impurities. So here the metamorphism has not much effect. The same quartz will recrystallize into another quartz grain. There will be hardly any interaction. But in this case, lot of interaction you saw. This we have discussed. Now you come to this. This is your limestone. This limestone, you see, this limestone like this. Compositionally, this is calcium carbonate or magnesium carbonate, calcite or dolomite. Microscopically, you cannot distinguish. Only by chemical analysis you can do. So, if these are pure phases, calcium carbonate and magnesium carbonate, same thing will happen. Not much of interaction. Variations are limited. So, if metamorphism happens, temperature, pressure you give, it will be only crystallized as a calcite or magnesite, dolomite grains. It will be converting to a mosaic of calcite or dolomite. With higher grade, you will get very coarse grained rock. That you know why, because the differential stress is less at a higher grade. Now, then what is the use of reading these things? When there is no variation, why you should read? Now you see, this limestone or the dole stone, whatever you say, this rock invariably has some quartz grains. Impurity may be very less, like this, C, D, but there will be one quartz grain. It must be sitting in the intergranular space. It cannot be 100% carbonate grains. If it is 100% carbonate grains, you are free. It will be just a pure marble. But there will be some quartz grains. That is the beginning. That quartz grains makes the difference. That quartz grain interacts with this calcite or the dolomite, This quartz interacts. This calcite or this dolomite to bring a variation in the mineral assemblage. Different minerals form. If quartz is not there, then no interaction. Could you follow this point? Now we are reading for that. How these variations takes place, in the mineralogy in presence of quartz. It is a large implication. The very large implication. So we will read that. Now you see, before going to that, this zone you see, this zone and this zone. What is this zone? This zone is a transition zone. This is a transition zone. Transition means this cell is gradually becoming less and less, and the carbonate percentage is increasing. That is what now. So you could take a sample from here. So how there will be? There will be a calcite. There may be a dolomite. But in that, in here, there will be some chloride. There will be some muscovite. There will be some feldspar, potash feldspar. This will also come in the transition zone. So this you say as a impure limestone. This rock you always define as a impure limestone. Impure limestone. This is a pure limestone. This is the impure limestone. Why impure? Because there will be cell fragments. Could you follow this point? Now, these zones, I am talking about the transition zones. So because of the presence of these shelly portions or the pellitic portions, there will be a lot of interaction. Number of reactions takes place. Just like your pellitic rocks. Pellitic rocks, you saw so many facies, so many zones we saw. Na? A large variation because of the reactions between different grains. Same thing also happens here. So this will provide a chance, to study how the metamorphism is taking place in an impure limestone. But to go there, before that we should see this one. A pure limestone with a little bit of quartz. Understood, na? So these are the three constituents. One is a calcite, another is a dolomite MgO, another is quartz. These are the three components. How do they interact? How the quartz makes a difference? Should you follow this point now? Now, here you see how this limestone is forming. What is the process of formation of limestone? Limestone कैसे बनता है? You see from here, these are the mountains, You understood this diagram, na? This is your Eastern Ghats. You are sitting on Eastern Ghats. This is Eastern Ghats. Here is Bay of Bengal. Bay of Bengal. Now these sediments, they are carried out. They are carried by these rivers, tributaries into the sea. These are the chemical precipitates. These are the chemical precipitates. These are not chemical precipitates. These are clastics. Quartz is a clastic. They roll on the river bed or sea bed, or carry by the current, physical carriage. This is also same thing. Why this is forming here? Because it is lighter, so it is carried away. Why this is forming close to the shore? Because it is heavier, rounded, so it falls down. How about this? These are the dissolved materials. Dissolved materials from this rocky terrain. So from this rocky terrain, what are the dissolved materials? Calcium, sodium, potassium, magnesium. All these elements, they are dissolved in the water. So as a dissolved ion, they go to the sea. So they all carried to this part, deeper part of the self. Deeper part of the self. And after reaching there, they precipitate. So how do they precipitate? Now this water, this water is in contact with carbon dioxide. This water is in contact with carbon dioxide. So this carbon dioxide plus water, it makes your carbonic acid. It makes carbonic acid. So the water is more or less an acid, carbonic acid. Maybe the concentration is very low. It is not acidic. It is alkaline, but it has a lot of acidic components. Say 7 is neutral, maybe 7.5, 7.8, 8 तक भी नहीं है. Though it is alkaline environment, but lot of carbonate ions are there because of the formation of this carbonic acid. So this carbonate ion, is produced from these carbon dioxides in the atmosphere. So this atmospheric carbon dioxide goes into solution with water, sea water, and forms this carbonate ion. So this carbonate ion, they form this calcium carbonate. Similarly, magnesium plus carbonate, they produce magnesium carbonate. So when they form these carbonates, then they precipitate. Small grains, they settle down and goes into the seabed. The sea foraminifers or the animals, they also consume them. The small droplets of calcium carbonate, magnesium carbonate to form their shell, their hard part. So most of the hard parts are either phosphatic or this carbonate, 90% is carbonate. So where from they come? They come from these pellets, small pellets, calcium carbonate, magnesium carbonates. So when those animals die, they also fall on the seabed. So you get a biotic limestone or an inorganic limestone. Suppose it is not the fossil, it is precipitation. So it is inorganic carbonates. That is how these carbonate beds develop. So primarily this carbon dioxide goes into the rock. This is called natural sequestration. Natural sequestration. Natural sequestration. Sequestration means carbon dioxide from atmosphere it takes and goes into a deposit. Nowadays people are doing artificial sequestration because the carbon dioxide percentage is very high in the atmosphere. So they capture the carbon dioxide by various means करके उसको डिजॉल्व करके माटी के अंदर छोड़ देते हैं. That is called artificial sequestration. But this is a natural sequestration which nature has developed, to make a balance between carbon dioxide in the atmosphere and carbon dioxide in the sea. So sea is the major reservoir of carbonate. Remember, right from say Proterozoic time or Archean times, since during Archean time there was carbon concentration was very high in the atmosphere. Now it has been reduced. How it was reduced? See, these oceans started bringing it down. They dissolved in the water and formed the carbonate rocks. So remember, during beginning of the Proterozoic time, the carbonate rocks becomes maximum. Archean time में carbonate rock इतना नहीं था. But जब Proterozoic time में आया, Proterozoic time when it started at 2600 to 2500. That time, this carbon dioxide percentage in the atmosphere reduced to this level. Today, whatever you are seeing, it reduced to that level, 2 ppm or whatever maybe, it reduced. Now that reduction, because of the big oceans were formed. Archean time में ocean नहीं था इतना बड़े बड़े. Even if it was there, they are all lava flows, lava oceans. Not the water body, Bay of Bengal water body oceans. But during Proterozoic time, these water body oceans were created. Very big as today's ocean. So those carbon dioxides were taken into the water. The limestone beds started depositing. So major carbonate beds are all Proterozoic age, not your Archean age. आप कहीं जाओ, आरावली चले जाइए. You go to Central India Tectonic Zone, go to Singhbhum Mobile Belt. There are a lot of carbonate beds are there. Either impure calcilicate rocks, impure limestone, or pure limestone. They are all Proterozoic phenomena, not Archean phenomena. Understood na? The reason you understand na? So this carbon dioxide is trapped in the limestone. Point of telling all these things is the carbon dioxide is trapped in the limestone. Now it is going to be metamorphosed. Could you follow this point? Now, neither quartzite, this sandstone, it has no carbon dioxide. It didn't trap. This also didn't trap. Only this trapped. Only this trapped. So when the metamorphism is happening here, this carbon dioxide has no role. Water has a role. H2O has a role. Could you follow this point? But in here, since all the minerals are having carbon dioxide, dolomite ho or calcite ho, they are having carbon dioxide in it, in form of carbonates. So this carbon dioxide has a role to play in the metamorphism. You understood this part, na? So carbon dioxide has a role to play in metamorphism. You will understand why I am telling this carbon dioxide. This is not at all active in these two regions. Well, water ठीक है. Now you see, I'll just remove this diagram. So the rock is something like this now. This is a calcite, maybe a dolomite. There is a quartz here, like this, This is the sedimentary rock. See, this carbon dioxide is here inside the grain. Carbon dioxide is inside the grain. But between the grains, see here, I have already we have discussed, there are fluid. भी फ्लूइड ट्रैप होता है ना, ये तो यहाँ कॉन्टैक्ट इज वेरी शार्प, बट जहाँ क्वार्ज है, क्वार्ज इज ए क्लास्टिक ग्रेन, ये क्लास्टिक ग्रेन है, दिस इज ए क्रिस्टलाइज्ड ग्रेन है, सो देयर विल बी गैप हियर ना, सो देयर योर इंट्राक्रिस्टलाइन फ्लूइड विल बी देयर, जस्ट लाइक इन केस ऑफ पेलेटिक रॉक्स वी हैव डिस्कस्ड मेटामॉर्फिक फ्लूइड. So the metamorphic fluid will be occurring here. This fluid will be having what? Water, carbon dioxide. यहाँ भी carbon dioxide होगा. Because whole environment is full of carbonates. So यहाँ भी carbon dioxide होगा, यहाँ भी water होगा. Could you follow this point ना? So this is a metamorphic fluid. Metamorphic fluid. Yeah, intra or intercrystalline fluid between two crystals. Yeah, but which the carbon dioxide which we are talking in the lattice, in the mineral, that is the carbonate mineral. But follow this point. Now you see, आप कार्बन डाइऑक्साइड लेके तो कैल्साइड बना दिया. अभी नाउ सपोज आप मेटामॉर्फिज्म करेंगे. Suppose you are going to metamorphism. Metamorphism means what? You can discuss in two ways. One is a contact metamorphism. Contact metamorphism आप कर सकते हैं, और a regional metamorphism. Regional metamorphism. Contact metamorphism, as you know, there should be a pluton. Pluton could be a granite pluton, or it could be a gabbro pluton also. This is a granite pluton. This one is a gabbro. I am giving two examples, means either of them. These plutons, if it intrudes into this rock, then this will produce a contact metamorphism because temperature is high. So in the contact areole, these minerals will react. In the contact areole, this calcite, dolomite plus quartz, they will react to form different minerals. Or if it is a regional metamorphism, in case of regional metamorphism, what will happen? Regional metamorphism, the symbol you can give like this. That limestone is being buried. Limestone is buried. That is regional metamorphism. So these are the two principal metamorphisms. So in case of contact metamorphism, you are providing heat from an external source. Regional by depth, that geothermal gradient. What is the difference? In this case, pressure is not high because this occurs within the 3 km of the crust, maximum 3 km of the crust. Here pressure is not, which pressure? Lithostatic pressure is not high. Lithostatic pressure is not high. Lithostatic pressure, you understand, na, is not high. But in this case, ये तो 10 km, 15 km, it takes down ना. So in this case, lithostatic pressure is very high, just like regional metamorphism. Pressure is high because the metamorphism starts from 10 kilometer, 10 kilometer downward. Downward. Difference is this. There is a shallow water, a shallow metamorphism, but temperature is very high. You remember your PT diagram, that slope, very low. Remember another diagram, dp by dt or p by t. The point is, suppose let us take this case first. This case what happens? In this case, ये जो लाइमस्टोन चारों तरफ पड़े हैं, I'll just remove this part. ये जो लाइमस्टोन पड़े हैं, सपोज दिस इज ए प्लूटोन, मैं ग्रेनाइट प्लूटोन में ले रहा हूं, ये सब लाइमस्टोन है, ऐसे ये लाइमस्टोन है, limestone. So limestone is there, from below you have a pluton. So this temperature will be very high here. How much will be the temperature near the limestone pluton? So let us take it 700 degree centigrade. Gabbro pluton होता तो 1000, 1200 or even more, 1400 तक होता. Let us take granite pluton, 700 degree centigrade. Now gradually this temperature gradient will come down, and here there will be no temperature, 0 to 700 degree centigrade. So the which you say is the contact aureole. Understood? So now you see this limestone. This limestone, you have calcite. Suppose calcite is there. ये क्वार्ट्ज के साथ ही रिएक्ट करेगा. I told you. Calcite and quartz it will interact ना. तो कैल्साइट का जो कैल्शियम कार्बोनेट है, ये SiO2, ये दोनों रिएक्ट करेंगे. करने के बाद क्या होगा कि कैल्शियम सिलिकेट बन जाएगा. सपोज कुछ भी सिलिकेट बन गया, आई जस्ट गिव इट, प्लस क्या होगा इधर CO2 निकल जाएगा. देखिए बैलेंस करोगे तो आप मिल जाएगा. जो कार्बन डाइऑक्साइड के लिए इतना माथामुड़ी कर रहे थे आप, the carbon dioxide which has been sequestrated in the rock, because of the metamorphism it is again coming out. You understood this part now? It will not remain there because you are forming a silicate mineral, because quartz is there. If quartz is not there, fine, calcite will recrystallize into another calcite, so carbon dioxide will be stored. But if you have quartz, then you cannot keep carbon dioxide inside anymore. Carbon dioxide will come out. तो follow this point ना. तो जहाँ से volcanic eruption होता है, volcanic, कहीं ग्रेनाइटिक